For most people, the concept of an ecosystem brings to mind rural or wilderness areas, and indeed, most ecological research of the past several decades has focused on these remote settings. But today, the frontiers of ecological research can often be found in our cities, the places where most people live, work, play, and where everyday decisions like housing, transport, consumption can have profound effects on the environment. The objective of this lesson is to give you a first approach to urban forest ecology. One important element of urban ecology is the role of trees in providing a wide variety of environmental benefits, such as sequestering of carbon, thus contributing directly to climate change mitigation, reduction of air pollution through direct deposition of pollutants and through cooling effects, shading of buildings, which can lower energy demand for air conditioning, reduction of urban heat island effects, interception of water runoff, thus buffering local waterways from pollution and helping to control stormwater overflow problems, provision of habitat for wildlife, and access to nature. Two of the fundamental concepts of urban forest ecology are structure and function. Structure is the array of static attributes of the urban forest, the concept that asks the question, what is where? Examples of structure include the spatial distribution of species, biomass, size, age, and condition classes, the attributes one would note in an inventory of all trees in a city. Function is the dynamic operation of the forest, how the vegetation interacts with other components of the ecosystem, including humans, and how internal and external forces change urban forest structure over time. The species composition of a forest can be defined by its dominance and diversity. Relative dominance is a species percentage of the total basal area of all species. With diversity indexes, relative dominance can be a measure of differences among management units in an urban forest or mean of showing how the composition of a forest is changing over time. Diversity can be an attribute of urban forest sustainability. For urban forest, there is a level of diversity that can support stability if the latter is defined as a state resistant to catastrophic loss. Excessive diversity, however, may increase management costs to the point at which the stability of the urban forest is threatened. Ideally, the array and location of sustainable tree species would be so diverse that no single species would represent more than 5% of the tree population across the municipality, or more than 10% in any given neighborhood. In a worst-case scenario, the entire municipality's forest would be dominated by no more than a handful of species. The urban forest ecosystem services include benefits in human thermal comfort, urban catchment hydrology, urban soil and water pollution, and air pollution. Microclimate cooling and human thermal comfort benefits can be expected from well-developed street tree canopies. An increase in tree canopy cover over time will lead to an expected decrease in overall urban air temperature. Wind speed and mean radial temperature decrease on the tree leeward side of bare trees. Sheltering effects are more pronounced as the tree branch area index increases. According to previous studies, maximum midday air temperature reduction due to trees are in the range of 0.04 Celsius degrees to 0.2 Celsius degrees per percent canopy cover increase, and a canopy cover in excess of 40% has a larger effect on temperature reduction. Tree crowns intercept rain and reduce the amount of water reaching the surfaces below. Trees, in turn, can increase the return of runoff to the atmosphere through transpiration, providing associated air cooling benefits. For example, interception on residential properties with relatively high canopy cover in North Carolina, USA, was measured at 19.9 to 21.4% of total precipitation. Urban runoff, streams, and waterways frequently experience pollution. Urban trees have the capacity to remove nutrient pollutants and some heavy metals from stored water to provide water quality and pollution reduction benefits. Managers can select tree species or genotypes that provide the greatest air quality benefits. Tree photosynthesis in urban green spaces is able to offset a fraction of the CO2 emitted from traffic combustion engines. It's also important to identify tree species that are most responsible for allergic reactions. As an example, in 1994, trees in New York City removed an estimated of 1.8 tons of air pollution at an estimated value to society of $9.5 million. This example gives us an idea of the importance of the benefits produced by urban forests.